Hello again. This is Mary Jade Jakosalem, and I am currently enrolled under the AMA University Online Education. And for this video, I will be doing at the same time discussing my second laboratory exercise for the subject ITE 7104. The laboratory exercise 02 is on building network topology and design. So to start with, this is the Word document file that was given. So I will also like to open the Cisco packet tracer. Okay. So here, once again, this is the Cisco packet tracer. So here, to start with, I need to choose the simulation mode. So this is what I will do. Simulation mode. And then I have to single click on the end devices and single click the generic host. I have to choose PC and move it by dragging the cursor into the topology area, just like the picture shown below. So I will go here to the end devices, and I'm sorry, I need to drag a PC. So this is it. And then I need to add 3 more PCs. So 1, 2, and 3. Okay. Afterwards, I have to connect PC0 and PC1 to switch 0 and PC2 and PC3 to switch 1. For this assignment, I have to use the model 295024 for the switch. So here, let me go to the switches and let's go to 295024. So I will be adding 2. Okay. Then I have to connect PC0 and PC1 by first choosing connection. So I have to click the copper straight through cable. And I have to configure PC0 by clicking it once. I have to choose fast Ethernet and drag the cursor to switch 0 just as shown below. So here, this is the copper straight through. And then from here, I have to choose the fast Ethernet 0 and connect it to fast Ethernet 01. Okay, and then fast Ethernet 01. So right now, there is a... Why is this? I need to have a green light and an amber light. So let me try again. Let me delete this one. Okay, so now there's a green light on PC0 Ethernet and an amber light here at the switch 0. It means that if there's an amber light, it is not yet in the forwarding frame. So it's not yet forwarding frames. However, after 30 seconds, the amber light is supposed to change to green, indicating that the port has entered the forwarding state. So I have to repeat steps 5 to 9, but this time I have to use PC2 to PC3 to another switch. So I will connect na this one as well. I believe after 30 seconds, it will turn green. And that's it. So this one, I think it's after 30 seconds already. The connection between PC0 and switch 0 both now has 2 green lights. So I believe the 3 remaining amber lights will turn into green lights soon. So here again, going back, I have to create the 5 topologies discussed in the previous lessons using 5 PC, 3 laptops, and 1 printer, and at least 2 switches or hubs. It will depend on my design, and there should be a green light indicating the frames are already forwarded. So I will start first with the bus topology. I will just be creating it all here in this one document. So just let me include some text here. So first, I need to include the bus topology. So for the bus topology, again, I need 5 PCs. Okay. So 5, 3 laptops, and one that's 9. So I will add first the switches. So it's easier for me. So I'll just use the same switch. Okay. So there are 9. 2, 3, 4, 5, 7, and 9. Now I will be adding 5 PCs. 1, 2, 3, 4, 5. Then 3 laptops. 1, 2, and 3. And lastly, 1 printer. Now I'll just have to connect all of them. Is it? Yes. It will take a while. Actually, right here above, as you can see, everything now is in green because it was after 30 seconds already. Okay, and then the last one. Just move it around. And that's it. This is our bus topology right here. This is the bus topology, Sharon. And then I believe in a while, the rest of the amber lights will now turn to green. So now I will proceed to the next one, which is the star topology. So again, I will just write it here. So I need the star topology. So still have to use the same devices, right? So I will just copy paste. I'm lazy. Let me copy and paste. So let's make a star. Okay, start topology. I will have to, since I need two switches, I will just create two stars if that's the case. Okay, I need two switches per topology based on the instructions. Mm, mm, mm. Okay, then let me connect them. It's always like this way. And then this is a star topology now. I will create another one. Sorry. Okay, now this is the star topology. I know that the second one doesn't look literally like a star because you only have four components. But anyways, this is a star topology. Using the 5 PCs, 3 laptops, and 1 printer. So 5 PCs, 3 laptops, 1 printer. Then the next topology is the ring topology. Okay. So let me put some text here. Ring topology. Okay, I hope we're all good. Start topology, then the ring topology. For the ring topology, let me first some switches because it's easier for me. So I need 9, 2, 3, 4. Oh, sorry. 5, 6, 7, 8, 9. Wait. Let's make this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yup, it looks ugly. Wait. Okay. Now 5 PCs. Three laptops. Three laptops. And 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And 1 printer. Okay. Now let me connect everything to make a ring topology. So Mhm. And this is a ring topology. So bus, a star, and ring topology. Now, let's move on to what's next? Mesh topology. What happened? What happened? Okay, again. Why? I don't know why it's like this. But anyways, let's see. Okay. Still here. Okay. For the mesh topology now, mm, perhaps I'm thinking 6 and then 4. Okay. Let me copy this one. It's easier. And then wait. It's lagging. Okay. Let me just copy it real quick. Okay. Okay, done. So now make a mesh topology. Only have 6. Delete some. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then this one. Wait, it's complicated. Okay. Mhm. 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 Okay. So, delete muna this one connection. And uh, and then, okay, last one. We're going to make a mesh right here. So, one, two, so I have to connect it here. Then connect it here, one. And then this one, I have to connect it in, connect it here, and connect it here. Then for this one, we have to connect it here. And yeah, I guess that's a mesh topology. Yeah. Oops. Why is this in red? Okay. So this is the mesh topology. It's an example of a mesh topology. And the last one is a hybrid technology. I don't know what's happening. Hybrid. Ah, topology. It's topology. What am I talking about? Why is it? Okay, last one is a hybrid topology. So I still have it's hybrid. Just gonna create one from scratch. And 4. And I need again 5 computers. 5 PC. Let's connect them first. And then 5 computers. I still need 2. Let's put it here. Let's put it here. Then sorry. And then I need 3 laptops and 1. I'm going to put this one. So 1, 2, 3, and 4. That's it. So just to recap, I have here first, this is a bus topology. This one. Then we have the star topology. Then we have the ring topology. What's an amber? And then we have the mesh topology. I believe this will eventually turn into green lights. And then the hybrid topology. So now going back to the activity, I have some questions that I need to answer. So first, what does amber and green light indicate in the Cisco packet tracer? So let me start with it. A green light indicates, I believe that a green light indicates that it is now in a forward state. So it's forwarding data. So that is what it means when it's in a green light. So a green light means indicates that it is in the forwarding state. So it is forwarding data. That's what a green light is. Meanwhile, an amber light indicates that it is not yet in the forwarding stage. So it's not yet forwarding any data. However, after 30 seconds, if there is no loop, the amber light is expected to turn green. So again, an amber light means it's not yet in the forwarding stage, and a green light means it's in the forwarding stage. But however, if there are no complications, usually the amber light will turn into a green light. So what is the function of the switch and the hubs? So a switch. So actually they're very similar, that they are sometimes being confused, but as far as I know, a switch connects it connects devices together in a computer network. Switches, however, uses MAC address to identify the data to identify that the data being the data, sorry. Okay. So what is the function of a switch and hub? So basically, they're basically same devices that enables you to connect to a computer network. However, the difference is that the switch uses a MAC address to identify that the data is only transmitted to the device that requested it. So for example, PC1 is the one that requested it. The data is only going to be transmitted to PC1. However, a hub also connects multiple computers, but they make it act as a single segment, meaning once a hub broadcasts data, all the data is broadcasted to all the connected workstations, computers, or end devices. So that's the main difference. Number 3, what do you think is a topology that uses single medium? bus topology. For me, it's bus topology because it uses only one wire as far as I know. So it uses and a wire or a cable is a medium. So bus topology is my answer. So what can you conclude from this activity? After finishing this activity, I was able to map out different types of topologies in the Cisco using the Cisco packet tracer. Where am I? Using the Cisco packet. I can say that different topologies have their own unique arrangements with the same aim of connecting, of creating. So I had I had created 5 topologies: the star, the ring, the mesh, the hybrid, and the bus topologies for this activity. So it was nice that I was able to map out different topologies using the Cisco packet tracer. So I guess this is it. This is the end of the video. And thank you so much. I hope you had a good time.